The transistor, known by many as the most important invention in the world, powering every single computer, yet not too many people know how it works. So let's take a look. If we imagine this drawing as a bigger version of this transistor, you can get a better idea of how this thing works. So you can imagine the transistor as a wire with a switch. So the wire has two ends, here and here, and electricity can flow in through the collector, and then it'll stay here until it's allowed to go through this wire and come out this end. So it comes in through this end, and then it leaves this end. So this end is known as the collector, and this end is known as the emitter. Now you may be asking two questions. What is this thing for? And how does the electricity get from over here to over here? So the base over here, this is known as the base, and the base is the switch. So when the switch is powered, when you give a signal to the base, electricity is allowed to flow from the collector up and into the emitter. And so if I hooked up power over here, there would be no power coming out of here until I give a signal right here. Once the signal comes in through here, electricity is allowed to flow through the collector and out the emitter. So again, we can imagine this as a switch. Electricity can flow into the first end, and then it'll stay here, but it won't go to the other side because this end of the wire is out of the way. It doesn't connect. But if I were to physically take my finger and push this wire in, then now this wire is connected and electricity is allowed to flow in through here and come out through the other side. Now instead of using a finger, you use electricity. You power electricity through this end right here, and it allows the switch to close. So how do you give it electricity? Well, you can see I wrote NPN right here. NPN stands for negative, positive, negative. So that means that these things are polarity sensitive, which means that the collector, the thing that you put in power through, it only accepts power if it's negatively charged. And the emitter emits, or it sends out the same signal from the collector, which means that it's going to take this negative signal and it's going to output the negative signal. And then over here, in order to power the base or signal the transistor, you use positive energy. And so once you have a positive signal coming in through here, it lets the negative signal go in through here and out the other end. All the positive does is signal the negative to flow. So there's also something else called the PNP transistor, which I won't go over, but effectively it's just the NPN but switched. So yeah. Now, what can I do with the knowledge of this transistor? Well, many things really. One of them being logic gates. And so this over here is a simple logic gate. It's called a buffer. And so it takes in an input and it gives an output. So the input is 1 and it'll output a 1. If the input is a 0, it'll output a 0. So how does that work? Well, over here, this is how we use a transistor. So you can see we have negative charge coming in through the collector, and so it sits in the collector, but it can't flow over to the emitter yet because it doesn't have signal from the positive. So what we do is we take a positive signal, positive charge, and we send it through a resistor. And the resistor is only used here because the positive lead in our transistor is a bit sensitive and doesn't like overwhelming voltages. And so we're going to use a resistor, and we're going to send that signal into the base, and it's going to let the negative charge flow through the collector and then out the emitter. And once it flows out the emitter, it can charge this LED, which is also connected to the positive rail. And over here is the resistor, so we don't burn out the LED. So over here, this is what it looks like. So we have a 5-volt DC, 5-volt DC power coming from this Arduino, and this just connects to my computer, and we're just using it for a charge. So you can see here that we have the transistor right here, and it's got our 3 pins, 1, 2, and 3. Kind of blocked a bit by this LED, so let's move that out of the way. And you can see that we have our blue wire right here, and blue means negative. So we're charging this collector, and then the base gets powered, and the base lets the collector's energy, which is negative, flow through the transistor and then out into this LED, which then connects to ground. Now this is probably the most simple gate and doesn't really do anything for us, but once you make more complicated gates and put them all together, you can make things like this. Now this over here is an incomplete adding machine. So it accepts inputs in through here and outputs them in binary out here. And so it'll add the two binary numbers over here and output it right here. So right now we only have 1 bit working, but yeah, so this is some of the usefulness of the transistor.